Good morning, Algebra 2. We are going to be covering lesson 45. Remember that we are skipping we're covering 46. Remember that we are skipping lesson 45. So if you don't see that in Canvas, it's because we are skipping it. Just, I think, a little too hard to do without being in person. So we are going to jump in. This is review from geometry. So if you liked geometry, here we go. We are going to be reviewing trig functions. Now, there are several, but let's go over the main three. So our trig functions are sine, now these are abbreviations, cosine, and tangent. Now I wrote the abbreviations, and these have to do with a side ratio. So I would say the sine of, let's say, the angle theta equals the opposite over our hypotenuse. Okay, so trig functions work with side ratios, meaning a fraction, one side over the other. The cosine of any angle, or the cosine of theta, is your adjacent over your hypotenuse. Notice they both have hypotenuse in common, and they both have hypotenuse as the denominator. And then the tangent of any angle, we use the Greek symbol theta, is opposite over adjacent. So these are our trig functions, and we use these trig functions to find a missing side. So let's also go over, you probably learned an acronym to remember this. It's the same acronym I learned, SOGA, TOA. It's an acronym. You can write it at the top of a test or your homework, but this helps us remember these side ratios. So OH, CA, so this is sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. Okay, so that's the acronym that we use to remember this. Now we also have our reciprocal trig functions. Now, hopefully you remember what the word reciprocal means. It just means to flip a fraction over. So the reciprocal of the sine function is cosecant. So we pronounce that cosecant. Okay, and it's actually opposite of what you might think. Notice the first three letters are cos. So it sounds like it would be the reciprocal of cosine, but it's not. So sine and cosecant are reciprocals of each other, which means that the cosecant of theta would be hypotenuse over opposite. Notice I just wrote the reciprocal of this ratio to give us this ratio. Cosine of theta is the reciprocal of secant. So that's spelled S-E-C-A-N-T. But again, we always abbreviate our trig functions to three letters. So sine, cosine, tangent all have three, and so will these. So the secant of theta is the reciprocal of cosine. So I'm just going to flip these over. So hypotenuse over adjacent. Last, and this one makes the most sense, cotangent, but we only write COT, so cotangent. So the cotangent of theta is the reciprocal of tangent, so it's adjacent over opposite. So there's not an acronym for this. Just know that it's the reciprocal, okay? So we're going to use both of these. We're going to do some examples. So I'm going to jump into our lesson practice, which carries over to 2 pages, not because it's long, it just didn't fit on 1 page. So in the book, our lesson practice. So we're going to find, I'm going to do all 6, even though the book doesn't ask us to. We're going to find all 6 trig ratios for angle A. So I'm kind of trying to word it a little bit similar to your test. It's the same in your homework. So I'm going to draw the following triangle. And here's A. We got 15, 39, 36. Remember that trig ratios only work. This is angle B, angle C. All right, so we're going to write all 6, okay? Notice they put angle A, so I only care about this angle here. I'm not really concerned with B and C. They want me to find it for angle A. So I'm going to label my sides accordingly. The side or the leg that is across from the angle would be my opposite. The side across from our 90 degree is hypotenuse, right? And this is because it's across from a 90-degree angle. And the side touching our angle to be next to is called our adjacent side. So based on that, I'm going to find the sine of angle A, the cosine of angle A, and the tangent of angle A. So all they want us to do is write the ratios. So I should just have fractions. I'm also going to show you how to convert those to decimals because the book has you do both. So the sine of angle A would be opposite, which would be 15. Right? Opposite of angle A is to be across, so I'm looking across. And then my hypotenuse is 39. And I'm going to write both. I want you to be able to reduce it and write it as a decimal. So 15 and 39 can both be reduced by 3. So that would give me 5 over 13. Or I can enter that in my calculator. You can either do the original 15 divided by 39. And I get 0.38, or you could say 5 divided by 13. We should get the same decimal. Or 0.38. So that would be whether they ask you for a fraction or a decimal. That is the answer for that. So the cosine should be my adjacent side, which in this case is 36 over the hypotenuse. And I didn't leave a ton of space, so I'm going to move that. I'm going to reduce these by 3, so that would give me 12 over 13, or that as a decimal is 0.92. So there's the fraction form of the answer and the decimal. Tangent of angle A should be opposite, which is 15, over adjacent, which is 36. Again, I'm reducing that by 3, so 5 over 12, or the decimal form, 0.42. Okay, now let's do our reciprocal. So cosecant of A, secant of A, cotangent of A. Now, if needed, you can use what we wrote above. Cosecant is the reciprocal of sine. So sine was 15 over 39, so the reciprocal would be 39 over 15. I'm still going to reduce that, so that's 13 over 5. Or as a decimal, 13 divided by 5 in your calculator, I got 2.6. The secant of A would be the reciprocal of cosine, so I'm simply going to write 13 over 12. Or it should be a different decimal because 13 divided by 12 is greater than 1. I got 1.08. And finally, cotangent should be the reciprocal of tangent, so 36 over 15 or 12 over 5 already reduced. Or I have to enter that in my calculator. 12 divided by 5 is 2.4. Okay, so that's how you find all 6. Real simple. We're not solving. We're just finding the side ratios. So let's do that for part B. I'm going to draw, and they gave us 16, 20, 12, A, B, C. And I believe they again asked us for A. Let me make sure. Find the reciprocal trig functions for angle A again. Okay, so reciprocal trig functions are cosecant, secant, and tangent. And I'm doing that for angle A, all three. So I like to mark it on my picture so I don't get confused with any other angle. So they're asking for this angle here. It doesn't matter whether the letter is outside or inside, it's still referring to the same vertex. Okay? So the way I do this is I first find the original because I don't have it memorized. And then I work backwards. So I'm going to label my sides just like we did. So across from 90 degree makes this hypotenuse. Across from the angle they're asking about is opposite. Next to the angle they're asking about is adjacent. So sine would be opposite, 12 over 20, which means cosecant is 20 over 12. And for this one, I think they asked it for decimals, so I think I got 5 over 3 or 1.6 repeating. I think they asked for the decimal. I don't have the book open. I closed it after I told you the page number, so let me look that up just to confirm, but I think it asks for your answers. Oh, it doesn't. So I guess if it doesn't specify, you can write either. Okay? So here, but if you give it to me in fraction form, then I want it reduced. So you could choose what to do here. These are both reducible by 4. 20 and, oh my goodness, Michelle. 20 divided by 4 is 5. 12 divided by 4 is 3. Or you could write the decimal version. It's up to you. So cosine of angle A would be adjacent over hypotenuse, which would be, 4 over 5. So I'm going to write the reciprocal of that. That's 5 over 4, or that's 1.25. I know that one by heart, so you could write either. The tangent of angle A would be opposite over adjacent, which is 3 over 4. Did you notice I messed up over here? So the cotangent would be the reciprocal. It would be 4 over 3, or if you prefer decimals, that's 1.33. So I do this first, and then I write the reciprocal. But it's up to you how you would like to do that. All right, so this is not in our book, but it is on a test eventually. Using the point -8, 6, find all 6 trig ratios. So there is a test question like this, and it's not in the book. So I want to make sure I do one with you. It's a future test, but at least you will have seen it. So the first thing I'm going to do is I'm going to graph and picture where that is. I've got, let's just say 2, 4, 6, 8, 2, 4, 6. That point would be here, right? -8, 6. So if I graph this point, I know, I'm going to draw a triangle. I know this is -8 because I went -8 to the left, and I went up +6. To find this missing side, we would do 6 squared plus -8 squared equals my third side. I need all three, right, if I'm going to use, I need adjacent, opposite, hypotenuse. Sorry. So the first thing I did was I plotted my point, and then I'm drawing myself a visual of my 90-degree angle, of my right triangle. Now I'm going to solve for that missing side. So 6 squared plus 8 squared. All right. I keep entering things wrong on this calculator. So I get 100 equals x squared. So x equals 10. So I know that this side here is 10. Now, here is theta. Theta is always at the origin, so that means that this 6 is opposite. means that -8 is adjacent, and the angle across from my 90 degree is my hypotenuse. So now I'm going to do sine of theta, because I don't know what my angle is, cosine of theta, tangent of theta. I'm going to leave mine as fractions this time. Then I'll do the reciprocal, so cosecant. I always put them across from each other, secant, cotangent. Notice I put theta because we don't know what the angle is, and they are not asking for the angle, they're asking for the ratios, so the side relationships. So sine of theta would be opposite over hypotenuse. That can be reduced to 3/5, which means cosecant is 5/3. Okay, right? It's the reciprocal. Cosine would be adjacent, so -8/10. This is a -8. It's really important. That was -8. So that would be -4/5. So the reciprocal would be -5/4. Tangent would be opposite over adjacent. Make sure you pay attention to that number. So that's 3/-4, which means the reciprocal would be -4/3. It doesn't matter where you put the negative. All right, so that should cover anything you see on your test and homework regarding ratios. Now let's move on to the next part, and that is solving for a missing side. And so I'm going to do some examples with you before we do what is in the book. So first example I'm going to do with you, here's the triangle. Here's my right triangle. It's not perfect. This is 6. This angle here is 20. And this is z. And they want us to solve for z. So let me move this up. Let me zoom in. All right, so this is how we use trig ratios to find or to solve. So I'm looking for side z. So I'm going to label what I have. And I'm going to use the only angle they gave me besides the 90 degree. We don't ever use 90. So they gave me this angle here. So I'm going to label my sides in reference to that angle. So, and I'm only going to label the sides they gave me. So 6, right, would be opposite because it's across from. Z is across from my 90 degree. So I have opposite and hypotenuse. So I'm going to write SOHCAHTOA. And I'm going to look at this and look what I have. I have O and H. So I'm going to use sine. So I would write it the following. The sine. And instead of writing theta, they actually gave me an angle. So the sine of 20 degrees equals my opposite side over my hypotenuse. Now to solve, I like to cross multiply. So there's a 1 here. So z times the sine of 20 degrees equals 6. I would divide by the sine of 20 degrees. And that is what I'm going to enter. So in my calculator, 6 divided by the sine of 20, and I get 17.54. So that is the length of my hypotenuse. Okay, so we're going to practice 2 more, and then we'll finish up our lesson practice. I want you guys to, this is review. You did this in geometry, but it's been a while, so, and it's COVID, right? Our brains are maybe a little mush. So here's another one. So here's 45 degrees, 5x, solve for x. All right, so I only care about the angle they gave me. And so they gave me 45. And so I'm going to label my sides according to the angle they gave me. So across from the angle is opposite. Touching the angle is adjacent. Now notice they did not give me hypotenuse. So I'm going to write SOHCAHTOA. I notice I have O and A, so I'm going to be using tangent because those are the sides they provided me with. So the tangent, I'm not going to write theta. I'm going to write the angle they actually gave me. So the tangent of 45 degrees equals 5 over x. I'm going to cross multiply. So x times the tangent of 45 degrees equals 5. I would have to divide. So x equals, and then using our calculator, 5 divided by the tangent of 45. Make sure your calculator, I should have mentioned this, is in degrees and not radians. And I get 5. I don't know why I put a little dot. This is not a degree. This is a side, so it should not have a degree symbol. Okay, so let's now go back to our lesson practice and finish the ones they gave us. So I only have, I believe, 2 examples in the book, part C and part D. So part C, so we're back to our lesson practice. Here is the following triangle. They said that this is 15 degrees. This is 62. This is x. All right, so I am solving for x. And I don't remember if this was a picture or a word problem. I know the last one, probably why I should keep the book open, huh? No, they gave us a picture. All right, so remember, we only care about the angle they've provided us with, and I'm going to label my sides according to that angle. So I notice I've got my hypotenuse because that's across from the 90-degree angle. And 62 is adjacent to 15. So TOA. I have A and H. So I'm using cosine. So the cosine, I'm not going to write theta because I have an actual angle, equals a same setup, 62 over x. So I already know I'm going to have to do x times the cosine of 15 equals 62. Divide. So x should equal 62 divided by the cosine of 15 degrees. Same setup each time. Hopefully they'll give us one that's not set up that way. So 62 divided by the cosine of 15, and I get x equals 64.2. All right, last one. This is a word problem. So when we have a word problem, draw a picture. Okay, it'll help you solve. So it says a surveyor is located. So I'm going to draw my little surveyor. He's located 380.7 feet from the base of the Chrysler building. Okay. It says that the angle of elevation from the surveyor, elevation meaning it would be from here up. The angle of elevation from the surveyor to the top of the building is 70 degrees. So from him to the building. Okay, and I don't know if you've ever been driving and you see a PG&E and they're measuring something. They're using tools, you can use lasers now to find the height. Even cell phones have the device where you can find like the distance and height. But anyways, they're asking, find the height of the Chrysler building. So they want the height of our Chrysler building. So now that I have a picture, and it doesn't tell us the height of this man, and that's why we're determining it from the ground. So I'm going to label my sides according to this angle. So I've got opposite, I've got adjacent. I'm going to figure out that my 90-degree angle obviously is with a building in the ground, and so they did not give me my hypotenuse. So the only one that doesn't involve hypotenuse is tangent. So the tangent of 70 degrees would equal my opposite over my adjacent. So finally, when we're not dividing. So I'm going to cross multiply. So the tangent of 70 degrees times 380.7 will equal, and when we cross multiply, we go diagonal. So I'm going to enter exactly that. The tangent of 70 times 380.7, and I get that my height is 1,045.96 feet equals the height. Okay. And that covers that lesson. For this homework, so for homework 46, I'll move that. We're going to be skipping numbers 13, 14, 16, 20, 24, and 30. Thank you.